back. We're solving July 21st question, even though it's already July 22nd. It's a hard question, bigger metrics with conditions. So let's look at the question. So you're given a positive integer k, and then you're also given a 2D integer array row conditions, where row conditions I equals to above I, below I, and column condition is this. It's kind of confusing. I'll explain it with a visualized way later. And then we want to build a k by k matrix that contains each of the number from 1 to k that for exactly once. And then the remaining cells should have the value 0. So this is actually saying that when we look at row conditions 1, 2, it means that 1 needs to be above 2. And then 3, 2 means 3 needs to be above 2. And then the column conditions 2, 1 means 2 need to be to the left of 1. And then 3, 2 means 3 need to be to the left of 2. And then strictly left and strictly right. So 2 and 1, in this case for column, you cannot be in the same column. All right. If it's not possible, and then we just return empty matrix. All right. I'm not going to actually code it out today. I actually have the code ready. I'm just gonna explain the high level visualizations, and then I'll walk you through the code that is pre-existent from editorial approach 1 that versus church. All right, let's look at July 21st. Yeah, I put in my profile picture here, and then PowerPoint just helped me to design this. So I found it very cool, so I put it here. All right, so let's look at some visualization. So the same example given. So the row conditions is 1, 2, 3, 2, and column conditions is 2, 1, 3, 2. So let's think about 1, 2 is like we have a 1 pointing to 2, and then saying that 1 need to comes before 2. And then when we have 3, 2, we say 3 comes before 2 as well. So you can think of this like a prerequisite of your class taking, right? You need to done 1, 3 first before you can do 2. So when I'm saying something comes before something, and then we think about it, we can think about the algorithm to call topological sort. So if you've never heard about that, topological sort is basically that given directed graph, it will first remove the one that doesn't have anything depend on it. So we'll remove 1, and then we add it to the list. We remove 3, we add it to the list, and then we remove 2. Since there's no more arrows pointing it, and then 2 is safe to be added to this list. And then we return 1, 3, 2. But this is not just one way. You can also remove 3 first, and then remove 1, and then remove 2. But there's never a way that you remove 3 first, and then you remove 2, because 1 is still pointing at 2 if you remove after removing 3. Right. So this is a topological sort problem. So for rows, you know that, I'm sorry, this is a bad line. You know that we have 1 pointing 2, and then we have 3 pointing at 2. So for columns, we know that we have 2 pointing to 1, and we also have 3 pointing at 2. So for rows, you can see that we can potentially have 3. We say 3 and 1 are above 2, right? So we know 2 is somewhere here. So it could be 3, 1, 2, or 1, 3, 2. As I said before, that topological sort, it doesn't have just one correct way if there are multiple certain points. So after doing this, we know that since I already showed you that there's actually a depth first search, so you can see this as a graph, and then you want to do a DFS on it to actually do the topo sort for you, including DFS going through the graph. Right. So in a given way in the code, that actually the easiest way to do this is in a reverse way than you think. So we said this will be 3, 1, 2, but in the topological sort code that I will show later, they actually do remove 2 first. They actually remove 2 first because when they get to 2, they see there's no outgoing edges. So in this case, they edit 2 to here, and then when they remove 2, there's no outgoing edges for 1 and 3, then they add it here. You can do this and then simply just reverse it, to get the intended topological sort. This is just the reverse of this. And we also need to know when we have this, right? When let's move to another one. So let's say we have 3, 1, 2 for the row conditions, right? And then we have column conditions is 3, 2, 1. So the hardest part right here is when we actually need to put that in, right? So let's say this is the index, right? So we know that for 3, it falls in 0, 0. Oops, this is just so bad. Okay. And then for 1, it falls at row 1 and then column 2. And then 2 is at row 2 and then column 1. So this is how we need to put that in. Right. So let's look at the code together. So first, they build a topological sort, and then they pass in the row conditions and the column conditions, so they get an output of the order rows and order columns. And then if not, means the topological sort doesn't exist, and then just return an empty array. And then the setup is you do a matrix. So this is how you set up a 2D k by k matrix in Python. So we also do this for the day before, and then we return the matrix. All right, so we done this part. We're not explaining this part yet. So let's go into the topo sort. We know that we need a topo sort, and then we know that we need a DFS. So in this topo sort, we have an adjacency list, and then we say to the default dict, and then we have an order, and then visited. We also define this has cycle equals to an array of size 1, and then we default it to false. So for x, y in edges means that for a source and destination. So adjacency list you source dot append the outgoing. So you do let's say in this case, right? So when we have 1 going to 2, so we set 1 have an adjacency list 1, and then we have 2, and then we also set a 3 to 2, right? And then we set for I from 1 to n, and then we just start do the topo sort, and then we mark if this has a cycle, then we will return an empty array. So when we're calling DFS, and then it goes into this part of the code where we set the visited node to be equals to 1 when we're visiting it, and then for every neighbor of this node, we can find it from the adjacency list. And then if visit is 0, means that we didn't visit this yet, so we do a DFS on it. But if we found it has cycle 0, this means has cycle, which is the list that we defined earlier. And then if this means if this is true, and then we return because this is just false. And then if visited equals 1 means we detect a cycle, and then we set this has cycle to be true, and then we return. When we done, we just mark it equals 2 means that we done visiting it, and then we'll add it to the order. So when we adding this means that there's no more outgoing edges, which is what I said just now. So we can add it to the order. So when they return, you get and list of the order, and then it's in the reverse order. So when we reverse it, you get the intended one. So it comes back to here. You actually get the order from the topological sort, and then this is just what I mean when I said about this pair, right? You have a map that you're trying to find the index of it for both row and column. So this is taken care by this project code. And then at the end, we just go through from 1 to k. And then if the num is in the post row, also in post column, then we take that out and then set that row and column to be equal to the number. At the end, we return the matrix. This is a hard questions. I admit that I'm not doing the perfect job in explaining this. I'll recommend, if you have time, you can watch NeetCode. It's a 25 minutes video, I guess, explaining this question. So I hope this is helpful, at least for visualizing and explaining the basic concept about topological sort and DFS needed to be used on this question. So fun thing is when I run this code, when I submit it, the runtime just beats 100% of Python user, but it doesn't really matter because the runtime is differ every time. But thank you for staying until now, and sorry for the delay. So I hope all the best in solving the hard question, and I'll see you in the next video.